minus 2. That's funny. I had not expected that. Neat. Anyway, so now integrate 1/4, right? X to the power 4 minus 3 over 2 x squared minus 2x plus a constant. So again, power rule, power rule, power rule for integration. Ooh, number 25 looks a little bit tricky. How are we going to do this one? Now, if you just try to solve this by asking yourself the question, what function can I differentiate and get back e to the cosh x, e times cosh x, e to the x times cosh x, I don't think you're going to be successful. All right, like just guessing the answer here probably isn't going to work. So like when I'm faced with something like this, the first thing I do is try to like break it down to slightly more familiar things. And to me, the exponential is more familiar than the hyperbolic cosine. So this is 1/2 e to the x plus e to the minus x, right? That's the definition of cosh. So we can multiply this through. What does this give us? 1/2, right? Integral of e to the x dx plus 1/2 integral of e to the x times e to the minus x dx. Yeah? So laws of exponents, we've got 1/2 integral of e to the 2x dx plus 1/2 integral of dx, right? Because e to the x and e to the minus x cancel out. They're reciprocal. So I'll do the second one. This is x, right? What's the integral of e to the 2x dx? We have to do a little bit of guesswork here. Not too bad. I'll put the 1/2 out front, yeah? So what do you want to put there? What goes in the blank? What function can I differentiate? Differentiate something, right? And get e to the 2x. What do you got to put in here? Could we put e to the 2x? I mean, that's what I would start with, right? But how does that go wrong? Well, chain rule says that that's 2e to the 2x, yeah? So that extra 2 is a fly in our ointment, but that's easy to fix. Just divide by 2, right? So 1/2 e to the 2x. We'll do it. And so answer, 1/4 e to the 2x plus 1/2 x plus a constant. (25). 26 is a lot easier. 26 is a walk in the park compared to 25. Integral 3 to the x minus e to the x. Here, I'll let you guys work on that. I'm going to write up the other ones while you're working on that one. 27. So what did you guys get for 26? I get 3/2 x squared, yeah, minus e to the x plus a constant. Did you guys get that? I hope you got that. Again, the integral of x is 1/2 x squared. The 3 rides along. The integral of e to the x is e to the x, and that's just how it is. The next one, what is e to the x squared, like that? How does that work? E to the x to this, all of that squared. Well, that's equal to e to the x times 2, right? Or e to the 2x. So what's e to the x to the, what's e to the 2x times e to the minus x? Right. So really, we're just looking at the integral of e to the x plus 3, which I hope we can do without a lot of thinking, right? That's e to the x plus 3 times x plus a constant, right? Because the integral of 3 is 3x. This one down here, I'll write down here. So you're looking at the integral of e to the x to the 1/2 power. So how does that work? Again, laws of exponent. That's integral of e to the x over 2. So at this point, I do a little, I think about it over here, right? If I have d dx of e to the x over 2, what do I get? I get e to the x over 2 times d dx of x over 2, right? I get 1/2 e to the x over 2, don't I? So what do I want to do in this case? So if you look back at the examples we've done, when we had 2, we divided by 2, right? If you look at number 25, when we had 2 in e to the 2x, we divided by 2, right? Now we've got a half, so we're going to divide by a half, right? But dividing by a half is actually multiplying by 2. So the answer here is 2 e to the x over 2 plus a constant. And you can see it from this calculation over here, right? Basically, you wanted to move this 2 and like multiply it over to there, because then the derivative of twice this is equal to that. So it's the same business again. What about 29? Any ideas? You guys had trigonometry, right? What was the important identity you learned? Mm-hmm. Yeah. So this one is 1/2 1 plus cosine 2 theta. So I'll just give you that hint. You can finish it. Yeah? Well, I'll finish it for you. That's theta over 2 minus, well, plus 1/4 sine 2 theta. The reason for the 4 is the same as we just did. When we have the 2, we divide by a half. We divide by 2, and there's already a half there. And this one, well, this is just 3/2 x squared minus, what's the integral of 1 over 1 plus x squared? I heard tangent. On the right track, inverse tangent of x plus a constant. So there you go. We'll talk more about these sorts of things towards the end. I'm just throwing it out there in the moment. There are ways of doing integrals if you know trigonometry. Yeah. So So next week, we will be looking at the area problem. All right, so I probably won't be anti-differentiating so much for the next couple lectures, but don't worry, we'll go back to it. It's an important skill. You need to be working on it. So I should have mission 7 posted sometime soon. I made this worksheet worth 20 points. It's either due today or tomorrow. So, all right. Questions? And I made that announcement. You guys have